In this question, we are given that x is binomially distributed with parameters 20 and p. We have the null hypothesis, p equals 0.7, and we have the alternate hypothesis, p is less than 0.7. For the first part, we have to find the critical region for the test using a 10% significance level, and then for the second part, write down the actual significance level. Here we have a one-tailed test. Let's go to the distribution application. Let's select binomial. Here, because we have p is less than 0.7, the tail is as shown here. We will leave x for now as 0. The num trial, we will set that to be 20, and p is 0.7. Let's execute. Let's change the value here to 10% because we are finding the critical region for the test using a 10% significance level. Now, what the calculator does is it rounds up the value and gives us where we accept h0. And you can see that is when you have x being 11. So, to be in the region where we reject h0, we have to take one less than this. 1 less than 11 is 10. So, the probability that x is less than or equal to 10 is equal to 0.047, etc. And this 0.047, etc. is less than 10%. So we are in the region where we reject h0. So, for the critical region, that is when we have x being less than or equal to 10. And for the actual significance level, that is 0.0479, etc. In this question, we are given that x is binomially distributed with parameters 25 and p. We have the null hypothesis, p equals 0.25, and we have the alternate hypothesis, p is greater than 0.25. For the first part, we have to find the critical region for the test using a 10% significance level, and then for the second part, we have to write down the actual significance level. Let us go to the distribution application. We have a binomial distribution. Now, because we have p being greater than 0.25, let's change the tail to the third option where we have x is greater than or equal to. We will leave x as 0 for now. Num trial, that is 25. P, that is 0.25. Let us enter in the 10% significance level here. So we have 0.1. What our calculator does is it gives us the region where we accept h0. And you can see this is clearly bigger than the 10%. So, because we have an upper-tailed test, we have to do one more than this, which is 10. And now you can see this value is less than 10%. So, the probability that x is greater than or equal to 10 is 0.071, etc. So, for the critical region, that is x is greater than or equal to 10. And for the actual significance level, that is 0.0713, etc.